Dr. Partha S Satvaya is working as Director of School of Illumination Science, Engineering and Design, Jadavpur University from March 2021 till date and previously from January 2017 to February 2019. He worked as Assistant Professor at Haldia Institute of Technology, Haldia, West Bengal in the Department of Electrical Engineering. He is the Fellow of the Optical Society of India and Indian Society of Lighting Engineers. He is also a member of Electrotechnical Committee 49, Bureau of Indian Standard. Welcome Dr. Satvaya.
Thank you very much for this opportunity. After long lectures, you will be bored, so I will not go in detail about the data and all those things. I will go through some pictures and most of the pictures you have already seen were attended my class. So starting from lighting, we know that when you think of a space, so in that case, after a year, light basically fills all the space, if the space is illuminated, of course. Right? So in this case also you can see there are multiple luminaires are also mounted over here. So my presentation is totally out of this context. I will go through energy and all those things, but in a different perspective. So in this case you can see multiple luminaires, those are illuminated with CSL lamps. This is a compact fluorescent. And I will go through by two terminologies. One is illumination. In the initial title page I have written illumination, and after some pages I have mentioned the lighting. There is a subtle difference between these two. When I talk about illumination, that is the general illumination. Okay. So in everywhere light level is same. But whenever we talk about lighting, so in some cases we do put more light and intensity, and in some spaces are kept dark. Okay, that is for light. So if I go to the first phase, this is the image. You can see that shows Leonardo da Vinci has drawn this diagram, and in the year 1490, a spot of it like this, that within our eye there is a lens over there, some kind of wall over there through which light goes inside, and there is a connection between whatever we see through eye and to our brain. So that can be seen over here. And after some biological anatomy and all those things, we know about that one, that vision is not only due to our eye but also due to our brain. That can be observed. Then, on the left hand side, the image can also be seen at the bottom. The eye can be seen, the front of the eye is basically at the bottom, and the concentration of different photoresponsive cells, how they are distributed. You know that photoresponsive cell is rod cell and coon cell. Normally it is focused towards the area, that is the fovea, where the concentration of the coon cell is maximum, that is responsible for giving the color vision. When I talk about red, green, blue, three types of coon cell, not exactly red, green, blue in that fashion, but basically low wavelength sensitive coon cell, medium wavelength sensitive coon cell, and the large wavelength sensitive coon cell. Okay. And when I go out of that fovea, there is totally rod cell, that is not color sensitive, but it can present the detection of basically it can detect the light. Okay, so that is the difference. So in this case, the signal we do get from our retina that goes to our brain, and accordingly we can see. And light is a very small part of the total electromagnetic spectrum that we can, or basically that creates a sense system within human eye, or it creates a sense system in human brain. So I have already shown you this picture. You are again at the classes. Okay, so this shows you the importance of lighting. Okay, so in this figure you can see that snow-capped mountains. Okay, and this is the picture that shows you the Grand Canyon. Basically the canyon. Okay, the difference between the images is that both the images are same. Only this is the rotated image. When I put, this is the real image. When I put this image upside down, that creates this image. Okay, so that is why the light, how we are putting the light and where we are putting the light creates an environment around us. So that we need to know. So in both the cases, we are considering one thing, that light is always coming from the top. Light is basically the sunlight, and it will come from the top, and that is why this appearance is created.
The performance is measured using this kind of chart, that is called Landau's ring chart. It is within an illuminated environment. The participants are given this kind of pages, and they are asked to find out the number of this ring which has opening on the right side, and you have to complete it within a certain time. Okay, and the performance is measured according. There are other ways also. This is one of the way it is measured, that how the light level is proper or not. Okay, if I go over to the outdoor lighting. Okay, so these are all facade lighting. When we illuminate the face of a building or face of a specific structure, that is the facade lighting. So in this case, the lighting is used for city beautification, that sometimes creates a prestige of a city. It highlights the historical building, all the structures. Okay, well-known structure with in the evening time, it improves the environment or improves the surrounding area, thereby tourist it becomes a tourist attraction place. So if I go for lighting, so what are the points that we need to think about? We have to provide proper illumination or adequate illumination. There should be good color rendering. Color rendering is also one of the factors that we must observe the real color of the object. But if the radiation or the light that we are getting from the source is of different kind, if it is not having all the spectrum, then the color will shift. Okay, so thereby we need good color rendering. We need to limit the glare. Light should not come to our eyes. Likewise, while you are observing this this page, this light should not come to your eye, otherwise it will create a bad sensation, and you will not be able to visualize the page properly. Okay, so that glare should be limited. Then we must avoid sharp shadow and all these parameters, and reveal surface textures. This is one of the important parameters. So in this image we can also see that so in this image we can see that at the top image it is creating a sharp shadow, whereas at the bottom image it is not creating that much sharp shadow. So here in this ball we can see that the shadow it is creating, that is a sharp one, whereas this is, it is hard to distinguish where that difference is creating from a lighted part and the dark part. Okay, So adequate illumination is possible by efficient luminaires. We need to think about the aesthetical aspects also, because light, sometimes we will find out within the space we will mount the luminaires, but in some cases the lights are not glowing, sufficient daylight is present over there. So in that case we just go for aesthetic, it should look good. Then optimized lighting design should be there. Then it must be adhered to the reference or standards by international or national standards. Okay. Going over to the spectrum of light. So in the earlier days we used to use different kind of light source, something like this, that may be metal halide lamp, that may be sodium vapor lamp, depending on the where we are using it. Okay. So in that case the full spectrum is not present. You can see that these are the spectrum. The white lines is the spectrum of the light source. Okay. This is just for reference image, whereas this is for an incandescent filament lamp or halogen lamp we do get. But whereas today we are going towards LED lamp. Okay. So in that case we do get the spectrum something like this. Basically, in most of the cases, the lights LEDs, those we do use, those are blue light emitting LEDs. We do put a phosphor, yellow colored phosphor at the top. Just by mixing blue and yellow, we get white light. So we can see there is a sharp magnitude maximum. There you can see there is a blue peak over here and there is a yellow peak over here. Okay, just by mixing that blue and yellow, we do get white light. So those are the most of the cases. 99% of the lighting using LEDs, those are blue light emitting LEDs. Okay. Next, going over to the color, how to specify the color. So when we go for this is a chromaticity diagram which is standardized by International Commission on Illumination. So they have standardized this diagram. This is the old model, 1931 model. Okay, it is modified to 1976 model where the diagram is little bit different. Okay, but in this diagram shows all the colors, those are possible. Okay, when these are mixed together, we do get white light. So basically color mixing, or if we want to get the dominant color of any kind of light source, that we can get from there. But basically in this diagram what it is done, a color is represented by a coordinate value. Okay, so basically two number specify a specific color. So this diagram is basically standardized. So if you want to specify a specific color, the coordinate value of that color will define what is the actual color. Then limiting glare, as I just told earlier. So in this case we can see when the light is coming from there, from a source, and it is going towards within our eye. So in this section of the retina where there are rod cell, so that creates a bad sensation and thereby it creates a glare. So that should be limited for any purpose. Likewise, when we want to read something and this is on a table, so this is the offending zone. If the light comes from this section, the light will be reflected from the surface and it will go towards our eye. And if it is not within that offending zone, it will not create that glaring effect. So glare has different types of glare. One is some discomfort glare and there is a disability glare. I am not going in detail about all those things. Okay. So just like going over to the different types of lamps. So going from incandescent lamp or the filament lamp, both these cases, incandescent, halogen lamp, these are filament lamp. From there we are going over to the discharge lamp. So these are previously used. So we can see tubular fluorescent lamp or compact fluorescent lamp that we can observe over these light sources. Okay, these are just compact fluorescent lamps. Okay, so whereas after that induction lamp is not that much popular, then there is metal halide lamp. Now we are dealing all with this LED lamps. Okay, and accordingly, if I go talk about the energy use, so in this spark unit of electric power it uses, thereby it generates a certain amount of lumen light energy out of that one. Okay, so in case of an incandescent lamp it is very very small, whereas in case of a LED system that we do use nowadays, it can vary depending on how we are what type of light source we are using. So that can vary from 70 to 160. This is a old data. Nowadays it will be from 100 to 160, 170 range. Okay. The life is also very big. So life cannot be the total life. I will in the subsequent slides I will show you how to measure the life of the system. But this is of course calculated data. Okay. Only up to 6,000 to 10,000 hours life is measured, or its performance is measured, and a calculation is done based on that, and the real lifetime is measured. Okay, just comparative analysis of different types of light source, and you know about what are the advantages of LEDs. I'm not going in detail about all these things. This is wide color range, high energy efficiency, and all those things. Cross section of a LED from a single chip LED to multi chip LED. You can see there is a multi chips over there, and we can get multiple color out of that one, or we can get multiple light from multiple sections out of that one. This is how a LED lamp works, and we can put different secondary lens over here. We can see that this is actually the light source. And after putting a secondary lens at the top of that one, we can very easily control the intensity distribution. That means in which direction light will go, and depending on the applications, we can use different types of lenses over there. So in this image, we can see that the blue, this is the raw LEDs. Okay, raw LEDs over there, and the phosphor coating is just far away from that one. That is very rarely used, but in this case we do get blue light, while going through the phosphor we do get white light over there. But in most of the cases the phosphor is mounted something like this one at the top of the chip. Okay, the total construction, and accordingly we do get white light. And nowadays we are getting multiple colors out of the LEDs. From, if I talk about the white LEDs, that also we do get different shades of white. That it could be cool white, it could be warm white. So in this case it is warm white, whereas when we talk about the bluish white, that is cool white. In between there it could be natural white. These are termed accordingly. This is placed on that chromaticity diagram. Okay, this is based on that chromaticity coordinate values, and the CCT parameter, correlated color temperature values, are also shown over here. These are different types of LEDs. Those are possible. In our laboratory we have made different kind of LEDs that can be tunable to different level just by putting one cool white and warm white LEDs and mixing them together. We can get different flux level out of that one, as well as CCT value variation. That can also be possible. Okay, we have got designed this one, and we know that for a filament lamp or a halogen lamp, that can be those terminals can be put on a 230 volt power supply. But if it is not, if it is a gas discharge lamp, or if it is a LED, so we need to use a driver or a ballast or a choke. Okay, so in this LEDs also, this is the driver for LEDs. So where there are multiple electronic components over there that converts this AC supply to this DC supply. That DC supply LED is nothing but a diode. So it operates on DC supply. It is, and not only that one, there is another function that it generates a high frequency signal. Sometimes what happens, when I put a 230 volt power supply over here, so that high frequency signal also goes back to the input side. Okay, to the power system it goes. That must be stopped by using a EMI filter over there. It should stop that high frequency signal towards our power supply. Otherwise, it creates a problem. So I was talking about the life of the system. Out of that, in this diagram, it can be seen only up to that green section it is measured, but rest of the part is based on calculation, and thereby the life of the LED is measured. So if I talk about the future of LEDs or the lumen power watt, if I say, so in this case we can very easily see that lumen power watt in 2020 or up to 45. So this is a data that shows that we can go from lumen output to a very high range, but almost about around 200 to 250 range it will saturate. Okay, light output will saturate. But if you go for mixed lighting, where just by mixing white color can be, I just told you that white color is made by using blue color LEDs. At the top of that, yellow phosphor is put it. There is another way that it can be done just by mixing red, green and blue. Okay, we can get that one, but in that case the cost is high. Where we want to use multicolor LED, in those cases we do use that kind of LED light sources. So this is the lighting facts about. If I go over a backside of any box on a lamp, we do get different data. Out of that, this data is not available in India, but this data is available in European or American market, where they can very easily see what is the light output, what is the efficacy, as well as the from the warm white section to the cool white section where it ranges. You can see there is an arrow that shows you what will be the color of the light. Okay, and this is the energy chart that shows regarding the characteristics of the light. So this is, we go for the luminous efficacy. Efficacy is the term that is used in lighting, that is same as efficiency. We talked light energy we are getting out of the single electrical power it uses. Then how much light energy we are getting out of that. Then the lamp price. Being an engineer, this is the most important part. Okay, we have to think about the cost of the system. Then lifetime lamp lumen depreciation factor. This is one important parameter. How the over time the light will reduce down. Okay, but in which way it will reduce down. So that we need to think, that whenever we are designing things for any space, we want to design a lighting level for this space, and after 5 years what will be the lighting level in that specific phase, and accordingly the design has to be done. And these are the other parameters related to that. If it is dimmable or not, we can dim the light or not. So those are few parameters or the characteristics that we need to go through. Applications wise, it could be of different type. Like in this case, the light source that we can see over here, all these are this kind of light source. Okay, light is going only downwards. Okay, there are other types of light source where we want to put the light in the top sections also. For general diffuse, the light will distribute in every direction in 360-degree angle. Mounting of the luminaires can be of different types. That can be recess mounted, that can be surface mounted, that can be suspended. All these are known to everyone. There is no nothing unknown over here. So that could be general lighting, that can be localized lighting, or local lighting, or composition of all of them. Like in this case, general lighting is provided by the luminaires, those are mounted on the ceiling, whereas local lighting is provided by this light sources within an industry where there is a heavy equipment over there. So on the tabletop, this light source is illuminating the tabletop. Certain machines are illuminated over there. So these are known things. It could be pendant type, it could be surface or recess type. Different way the luminaires can be mounted. So whereas this is the cove lighting where the light, we can see that light is coming out of that one, but the light source is not visible. So here in this case it is direct, indirect type. Some part of the light is going upward, some part of the light is going downward. So in this case it is all the light is going upward, and after reflection of that one it is coming downwards. It is wherever there is a multiple in our laboratories where there are multiple visual display terminals are there. So in those cases the indirect lighting is best suited. Okay, direct lighting creates problem, that creates glare to the eyes of the persons who are using those display terminals. You know about these different types of light sources. This is office lighting, lighting design. When we go for lighting design, what are the parameters that we need to think on? So we need to analyze the function of light, then its quality parameters. Do you want to a control mechanism over there or not? We need to choose proper lamp and luminaire characteristics, determine the number of luminaires and the position of the systems, and accordingly different lighting designs are done. So in this case you can see this room, a single room is designed. These are the simulated one. Here we can see that isolux diagram or iso lines can be seen over here. On the line the light levels are same on the working plane, and working plane is not on the floor but at a certain height, certain distance above on the it is normally on the tabletop. Normally on the tabletop this light level is measured. So it is an imaginary plane on the surface where you do measure the light level. So this is for a single room design. Oh, just going back. What's happening? Oh, okay. So in this case, multi-room design, that is using the Dialux or similar softwares can be used for design. This is a section, you can see this is elevated metro platform on our east-west metro section. So this is also designed on Dialux. Okay, and we have measured and we have found out. So this design was based on LED based luminaire. Okay, and I have asked one student to just illuminate the same section with conventional luminaires. Okay, it was years back. It was near about 2016 probably, 16, probably 18. In the near about 18, he was trying to do that. When I just asked him, just design the same thing with conventional luminaires. Okay, and he found out that payback period was near about 1 year. Okay, we got payback period is a very good value. So it is actual design was on LED, but we got the payback period after designing it with conventional luminaire. That's a very good result we have got out of that one. Some problem is happening over here. Okay, so now regarding the facade lighting, some designs I just shown. This is the real images which are designed on a software, and after designing this looks something like this on the software. Okay, so this is the real image of the building. After facade lighting, this looks something like this one. The side of the building is also illuminated over here, and out of that one we have also calculated how much light pollution it is created. Okay, so we have already heard about air pollution another pollution. Now we will be talking about light pollution. Okay, so the amount of light that is going around the building. So in this case, we have found out that on this surface how much light is going outside the building. Okay, because in most of the cases lights are on the bottom. Okay, so it is throwing light towards the building, and thereby how much light it is polluting the surrounding environment, that we have calculated for this case, and we have got results due to that one, something like this. This is regarding the light pollution data. So if I talk talk about this street lighting luminaire, so in this case we know this is a forward light, this is backward lights, and this is upward light. So basically all these lights, that upward light or backward light, light on the backward direction is unwanted. Only we want the light in the forward direction. We need to design all the lighting when we are utilizing in the outdoor environment. We need to think around on this. Some problem happening. Okay, so now coming over to the other part, that is the non-visual effect. Okay, so we know about I just told you about that visual part, that how it looks. Okay, designing can be done. There is a biological effect of light. Okay, so health and well-being is dependent on the lighting under which we do stay. Okay, normally in most of the time in our working hours we do stay under this artificial light source. Okay, so that also affects our performance. Okay, that we need to go through, and we know we know that circadian rhythms. We know about sunflower that follow the sun. Okay, in the morning again comes back. Okay, again it follows the sun. That also happens within human being also. So if I go over to the hormone level, specifically two hormones, one is cortisol hormone and another one is the melatonin hormone, totally dependent on light. Okay, so cortisol hormone is also called as stress hormone or activity hormone. Because of this cortisol hormone, we wake up in the morning. High level of cortisol level, we wake up. Okay, low level of cortisol in the near about night time, we feel sleepy. Okay, similarly melatonin hormone is also called the sleep hormone. Because of melatonin hormone, we do feel sleepy. Okay, so accordingly it follows. The body temperature also follows this depending on light. So this is due to a recently, not recently, almost about 20 years back, it has been discovered that not only that I just told about rod cell and cone cell, but there is a third receptor in our eye. Okay, that is called the ganglion cell. Full name is IPRGC, intrinsically photoresponsive retinal ganglion cell, but normally it is called as ganglion cell. That instead of going to the vertical cortex, it goes to a area within our brain that is called the SCN area, and from there, from the pineal gland, we do get melatonin hormone, and at the top of our kidney we do get cortisol hormone, and that controls our body clock, it controls our circadian rhythm and all these things. Okay, and accordingly we have also seen from the different literatures that blue light, presence of blue light, melatonin thing, accordingly in case of a red light, melatonin increases, under the blue light it decreases. Similarly in case of a cortisol, under red light cortisol level increases, and under the blue light it also increases. Okay. So probably most of the things I have already told to them. Okay. So due to this photoreceptor that happens, so ideally what is needed, lighting should follow the sunlight. Okay. Or for working spaces, it is it is advantageous. Our performance will increase if the light level is of dynamic kind. Okay, so in this image shows not only the color of the light but also the amount of light. Okay, so y-axis is the amount of light and the color can be seen near about. In this way, if it follows, the productivity also increases. This is also shown over here. The difference, there is a difference between these two. This is the office environment, whereas this lighting level is required for, or this variation of the color of lighting is required for elderly persons, home of the elderly persons over there. Okay. Regarding the daylight, you know these things. I'm not going in detail about all these things. Now we need to talk about lighting control. So depending on where we want light, where we do not want light, so according to that one, lighting control can be done by on-off switching, it could be by dimming, it could be by integrated systems or daylight integrated controls where the daylight is over there. We need not switch on the lights over there, or the lights near the windows can be switched off. Then we can create a scene like in this room. We can see this. Okay, it's working. So in this case, we are creating a scene. Okay, where all the lights are glowing though, but in the back side, light is not glowing over there. One light is flickering at the back one. That will create a very big problem. In the first image I said shown that that flickering also creates a very bad sensation to our understanding level and to our activity level. And occupancy sensing and control, depending if the space is occupied, the light will be glowing, otherwise it will not glow. So depending on that, we can put different kind of sensors over there. Sensors could be active type sensors, it could be passive type sensors. Sometimes the infrared radiation that comes out of human body, that sometimes sensed by certain kind of sensors, and in some cases like ultrasonic sensors that detects the presence of any human being over a space. That could be active type sensors, and different kind of sensors are also available. And another one is the lumen maintenance. We want to maintain the lumen light level, constant light level over the space. If the daylight is available, just switch off the section where the daylight is over there to keep the light level uniform over there. Okay. So we can go for different lighting control mechanisms. We just told about the sensors. Then again, going in this image, it can be seen that sensors can sense the presence of daylight over there, and accordingly it can dim to maintain the proper light level, required light level over there. Then we have heard about global positioning system. Now here it is IPS, that is indoor positioning system. Okay, within a shopping mall where you are, that can be understood by this one. Or if you want to look at something on out of the whole complex, you want to look at something where it is there. So depending on the position of the person, it will show where the person needs to go. Then smart control systems are also coming, and it is already in the market now. This is when I talk about the Wi-Fi system. We have already heard about Wi-Fi system, wireless fidelity system. We are in this case, light source itself will provide internet over there. Okay, so in this case there is a modem, or modem is over there. It can sense the signal that we are getting from the luminous, and accordingly there is another light over there that is not in the visible range, that is normally in the infrared range, that is not visible, that can be sensed by the system itself, and accordingly this is the future we are going towards. And that's all.